Welcome to the Frequently Made Mistakes review for Assignment 1A. I'm going to walk through common problems I saw people make when I reviewed their solutions, and we'll talk about some of the ways you can address them. First and foremost, please make sure to document your code thoroughly. I've provided comments for the class and for the various methods, but you need to document the code that you write. Also, please do not remove the to-do tags. I use those to be able to quickly find the areas of your code that I need to review. So if you remove them, I have to spend a lot more time hunting around trying to figure out what you've changed. So please keep those where they are. So let's start talking about some of the problems I saw. This is the unsynchronized array constructor that takes an initial capacity. This check here is unnecessary. It'll get handled through other parts of the code if you do it properly. This particular implementation is too complicated. You should just use operator new to create an array of object with the designated initial capacity. And also, please don't set M size to initial capacity here. It should start at 0, and you're either welcome to initialize it or just let it take its default value of 0 where the field is defined in the unsynchronized array class. There were a number of problems I saw with the unsynchronized array constructor that takes a collection. First, you need to make sure that you check to see if the parameter C is null before you try to call a method on it. If you call it the way it's done here, it should probably crash. And please make sure you're running the unit test, which should detect these kinds of problems. You also don't need to check to see if the size is 0. That can be handled automatically through other parts of the code. Now down here, there's lots of problems. Don't use operator new. You should use the c.toArray helper method instead. That'll do everything you need. Don't cast the results of something like this to element data. It makes no sense because element data is an array of object. You don't need to use an iterator here. You don't need to use a loop here. You don't need to use array copy here. You just need to use the toArray method that's defined on collection C. Similar kind of problem here. Make sure you check to see whether or not the parameter C is null before you do anything else. If it is null, you need to throw an exception. Also, you don't need to have a temp array here. You can just go ahead and assign the result of c.toArray. And you don't need to use the version of toArray that takes an object array. Just go ahead and use good old toArray because you're trying to return this as an object, which it will do by default. And you also don't need to make this check. I'm not quite sure what this is trying to do, but it's completely unnecessary. The elements for M element data have already been allocated earlier and correctly if you make the call to c.toArray. Down here are some other examples. This code is way too complicated. Don't need to do any of this kind of stuff. Don't need to do copy of. Don't need to make a new object in this manner. This code is very strange because it's allocating an object of called temp, which is an array of objects, and then right away it's turning around and reassigning it, which means that you're wasting the call to new, so you don't need to do that. You don't need to be calling array copy here. Everything is handled automatically by c.toArray. And you also don't need to do a plus equal here. Just use a good old assignment statement. Some little tips. This code here for isEmpty isn't really wrong per se. It just could be done more concisely. Whenever you find yourself tempted to write code that says, if some value, return false, return true, or else return true, or else return false, just go ahead and write that as just a simple comparison that can be used with a return statement and let the implicit conversion to a Boolean take place. Much cleaner. This code is also unnecessarily complicated. You just have to return that the M size equals 0, which will in fact be the case if M element data equals empty element data. This implementation of index is very clever, but it's also unnecessarily inefficient. You shouldn't need to convert the M element array into a list. And that doesn't really even work correctly because M element data is not necessarily, it's probably got extra elements in it that you don't want to deal with. You need to deal with things that go up to M size. So this is clever, but it's inefficient and incorrect. Lots of things people could do to improve index of. So one thing to be wary of is if you have code like this where you check to see if M element data sub I dot equals the parameter O, which is of type object, this will crash if M element data sub I equals null. And make sure you run the unit tests to catch these kinds of problems. They should detect those kinds of problems. We'll talk in a minute about how to avoid that type of a problem where things crash. Here's a similar example. This time we put a check in here. You don't need to put a check in here. You just need to change the ordering so that if you know that parameter O is not null, you can then say O dot equals M element data sub I. And so you just have to reverse or swap those order of those calls, so it'll be cleaner. Another thing some people were doing, they were having a single for loop where they had a pair of conditional checks. This is also way too complicated. Much better to have a single if-else statement that determines whether the parameter O is null or not, and then have two loops. And then each of those loops can do one specific thing. It's also possible, by the way, to use Java streams here. We won't require that at this point because we haven't talked about streams, but several people use streams and their solution was very cool. Here's some examples of what to do wrong with add all. Again, make sure you check to see if the parameter is null before you do anything else. This should be getting caught by the unit tests, so make sure you're running them and make sure you're understanding why they're blowing up when they blow up. Likewise here, if you get a collection of size 0, it doesn't require throwing an exception. You don't need to do that. You just need to handle it in the consistent way in other parts of the code. Also, please don't use iterators. Please don't use for loops for almost everything. I think there's really no reason to use for loops at all in assignment 1A. Instead, use system.array copy. Much cleaner, much less likely to have off by one errors, and also most likely more efficient too. Once again, let's take a look at some of the problems people had with the remove method. Don't use a for loop, use system array copy, so no loops. Though there's probably going to be a need for one loop for the undergrad version in assignment 1B, but I think there's only one place where you really need to have a loop. Here's a bunch of other problems. When you remove an item, don't make a totally new copy of the array and omit it. Instead, just go ahead and shift everything down by 1 or slide everything down by 1 or move everything down by 1, whatever you like to say, using the array copy operation. Down here, make sure that you don't do a copy if you're removing the last element in the array. So if you're removing the last element, there's no need to do a copy. And make sure you use things like size minus minus instead of size equals size minus 1. And then also at the end of remove, right before you return the old item that you just removed, make sure that you set m element data m size, assuming that you've resized m size properly, to null, which will enable the garbage collector to do its thing. So let's take a look at set. Once again, no need to reallocate a new array here. Wow, that's incredibly expensive. Just a set of value. Don't do that. Keep it simple. It's really quite simple. You can also use your get operation in the implementation of set if you want. This implementation of add returns the wrong value. It should return true if all goes well, if something was actually added to the array. And then a couple things I saw with ensure capacity internal. A lot of people aren't handling the special case where m element data is equal to empty element data, in which case you want to allocate default capacity elements as the very first thing that you do in this method. There's some other ways to implement that, but that's an easy way to do it. And then down here, this particular implementation was allocating an array of objects of size default capacity, but it was not being used anywhere else. So please don't allocate memory just to make it be wasted. Let's take a look at some of the iterator issues. This was something that the grad students were doing in assignment 1A. For assignment 1B, the undergrads will also implement the array iterator. So some of this discussion will be helpful there. You don't actually need to define a field that's an unsynchronized array. Instead, from within the array iterator, which is essentially a kind of a nested inner class, you can access unsynchronized array.this.some method, whatever method you want to use that's part of the array. So you don't have to define your own private field. As before, you can almost always write has next more concisely by doing something like return index less than m size if index is what you're using to keep track of the position in the iterator. You don't need to say if index less than m size, return true, otherwise return false. And then finally, make sure in the remove method of the iterator, not the remove method in unsynchronized array, that you update the position fields properly. And that's important because otherwise you won't get the right results next time when the tests run. So those were the frequently made mistakes that I saw in this assignment. A lot of people did very well, which is great. Everybody did a great job of submitting the Google survey form. Thank you so much. I really appreciate that. That makes life so much easier for the reviewing. So what you'll do now at this point is you will address my comments, if there are any of them, and you'll fold them into your solution for assignment 1B, which I will be releasing here very shortly. So from this point onwards, you don't have to worry about assignment 1A anymore. All of the code will get folded into assignment 1B, plus the new code for assignment 1B, and then that's ultimately what you'll be graded on after I give you another round of comments for your submission for assignment 1B.